Welcome to The Explainer. Today, we're diving into a paper that is so much more than just another theory. Think of it as a meticulously constructed engineering blueprint, a serious attempt to reverse engineer the quantum machinery of life itself, to finally get a handle on how consciousness might physically work. Okay, so let's start with the big one, the central challenge here, the timescale problem. You and I, we think in milliseconds. But standard physics tells us that any quantum state in the warm, wet, noisy environment of a brain should collapse, poof, in about a picosecond. Now, just to give you an idea of how fast that is, a picosecond is to 1 second what 1 second is to over 31,000 years. So how could something so impossibly fleeting be the foundation for our stable, continuous experience of the world? And that, right there, is the heart of the decoherence argument. For decades, it's been this giant brick wall, a kind of impossibility theorem that just shut down most quantum theories of the mind before they even got off the ground. The argument was simple. The brain is just too hot, too wet, and too chaotic for quantum mechanics to matter. End of story. But what if that core assumption is just completely wrong? This paper does something really brave. It flips the entire script. It argues that life isn't some passive victim of all that chaos. No. It's an active, highly structured quantum engineering project that has spent billions of years evolving ways to actively shield and sustain quantum states. And they give this whole sophisticated process a name: quantum vacuum engineering. The core idea is that life meticulously builds its own shields against chaos. It carves out these little protected zones, these decoherence-free subspaces, where the weird and wonderful rules of quantum mechanics can actually play out on a timescale that matters. Okay, so let's get into the nitty-gritty. How does biology actually build this quantum fortress? Well, it's not a single wall, it's a 4-layer, deeply synergistic architecture where every single part makes the others stronger. It's defense in depth at a molecular level. So here they are, the 4 layers. First, a structural filter to handle the heat. Then, a spin selection system that basically creates an electronic superhighway. Third, a way to build a powerful collective quantum signal. And finally, an active maintenance grid that powers and synchronizes the entire operation. Let's break them down.
So, layer 1. You can think of material's dielectric constant as its willingness to let electrical noise, or static, pass right through it. For regular water, that number's pretty high, around 80. But for this special, highly ordered, exclusion zone water that forms near proteins, that willingness just plummets. It drops by a factor of 10. It's kind of like biology is putting noise-canceling headphones on its most important molecular machinery.
Next up, layer 2. This uses one of life's most fundamental properties, its handedness, or what's called chirality. You know, like how your hands are mirror images? Molecules are like that too. And this asymmetry acts like a perfect spin filter, forcing electrons down a coherent, one-way path. That means they don't scatter around and lose energy as heat. It creates a perfect, dissipationless quantum superhighway.
Layer 3 is all about strength in numbers, teamwork. The paper argues that inside the highly ordered arrays of our microtubules, thousands of molecules can become phase-locked. They'd all start vibrating together, perfectly in sync, acting like one single giant quantum entity. This creates an incredibly powerful superradiant state, and its strength scales with the square of the participants. That makes it unbelievably tough and resistant to any local noise.
And the final layer, layer 4, this is just brilliant. This shield isn't passive, it's actively powered. You have mitochondria constantly pumping in ordered energy to maintain coherence. And at the same time, the rhythmic pulse of your heartbeat acts as this global timing signal, a kind of stroboscopic clock that resynchronizes the whole network over and over again. So, you put all 4 of these layers together. What's the point? What's the grand achievement of this incredible shield? Well, the paper argues its ultimate goal is to reach a very specific, fundamental physical threshold. And this is where it gets really concrete, because this is not some vague, hand-wavy metaphysics. The paper provides a quantitative model. Each layer systematically and synergistically crushes the thermal noise. That easy water shield brings the effective temperature down to 30 Kelvin. The CIS filter drops it again, all the way to 300 millikelvin. And then superradiance just plunges it deep into the microkelvin range. And here's the bottom line, the truly staggering result of all this engineering. The 4-layer shield creates an effective temperature for that quantum state of just 30 microkelvin. Let me say that again, 30 microkelvin. That is literally colder than deep space, and it's being achieved inside a warm, living brain.
So why does that number matter so much? Because at that incredibly low effective temperature, the game completely changes. Random environmental noise is no longer in the driver's seat. It's been sidelined. Instead, a much more fundamental process takes over, the Penrose limit. This is the idea that the state collapses under its own gravitational self-energy. It becomes the system's own objective, non-random internal clock.
Okay, I know what some of you might be thinking. This sounds incredibly wild, maybe a bit too speculative. But here's the absolute masterstroke of this paper. It doesn't just stop at theory. It proposes a series of concrete, falsifiable experiments to ground all of this high strangeness in observable, testable reality. First up, a beautifully simple idea. Can we actually test the quantum nature of consciousness by turning it off?
The quantum model makes a very specific prediction. It says general anesthetics work by physically shattering that collective superradiant state. If that's true, it would cause a measurable shift in the light being emitted by microtubules. Now, a classical model would never predict that, right? It assumes anesthetics only mess with surface receptors, not the fundamental optical properties deep inside the cell.
Okay, the next experiment is even bolder. It asks, can we actually prove that gravity, not just random thermal noise, is a key factor in how these biological quantum states collapse? The idea is to take these biological particles, put them into a quantum superposition, and do the experiment in space, in microgravity. The model predicts their quantum state will last significantly longer, which would directly link their collapse to the gravitational field. I mean, think about that. It's a test that could connect the machinery of life to the very fabric of space-time itself. So let's just step back for a second. If this model, or even parts of it, holds up to scrutiny, it represents a monumental shift. We'd be moving from just asking if consciousness is quantum to actually understanding how it's engineered. And the implications here are just profound. This could provide a real physical solution to the binding problem, why our experience feels unified. It could explain the insane efficiency of biological computation. It could open up entirely new avenues for medicine. And yeah, it might even provide a potential blueprint for building truly conscious artificial intelligence. Which leaves us with one final and pretty provocative thought. If this blueprint is real, if consciousness is really a property of this exquisitely engineered physical hardware, are we on the verge of not just understanding it, but of actually building it?